Hello everyone and welcome back to your own channel Unlock Chemistry. Today we will discuss functional isomers. In last lecture we have discussed chain isomers, position isomers and ring chain isomers. Today we are going to discuss functional isomers. As the name indicates, the isomers having same molecular formula but different functional groups. Then the isomers are called functional isomers. So we have compounds having same molecular formula but different functional groups. Then isomers are called functional isomers. And what are the examples of functional isomers? So first set of functional isomers is alcohol and ether. Alcohol and ether, they have same molecular formula but having two different functional groups for same chemical formula, same molecular formula. For example, we have ethyl alcohol, this is ethyl alcohol, or we can say ethanol, and this formula can be written in form of ether also. CH3 or CH3, we can see both have a same molecular formula, but one formula represents functional group alcohol and second represents ether. So both these are functional isomers. So we can write their general format also, general formula also. If we combine the carbons C2 H6O and here again C2 H6O, so we can represent in terms of N also, where N is the number of carbon atoms. So basic formula is CnH2n plus 2 and 1 oxygen. This basic formula represents two functional groups. One is alcohol and second is ether. So it is the first set of functional isomers, alcohol and ether. Both are isomers, functional isomers. Second is second important conclusion is all ring chain isomers are functional isomers. All ring chain isomers are functional isomers. For example, again we have three carbon alkene, that is propene. This propene can be represented in form of ring, that is cyclopropane. So this is alkene, but this is a cycloalkene. So this compound will show the characteristics properties of alkene, but this will show the characteristics property of alkane. So all ring chain isomers are functional isomers. Even we can use alkyne and cycloalkene. Alkenes, alkynes, cycloalkenes and bicycloalkene. They will represent functional isomers, right? They have different characteristics property. It shows the characteristics property of alkyne, alkene and bicycloalkanes. So all ring chain isomers are functional isomers. That is the important conclusion. So third set we have Third set we have aldehydes and ketones. As we know, ketone starts from 3 carbon, so we compare 3 carbon aldehyde and 3 carbon ketone. Aldehyde group is CHO and ketone is this is carbonyl bond. So if we have 3 carbon aldehyde CH3 CH2 CHO, this is propanol. But if we represent 3 carbon ketone, then formula will be, structure will be, now this is a propanone. But if we write their condensed formula, both represent C3 H6O. So C3H6O represents two functional group. One is aldehyde and one is a ketone. We can write their general format with respect to n carbon. So formula will be CnH2nO. Previous general formula was CnH2n plus 2 and 1 oxygen, that represents alcohol and ether. But if hydrogen is just double, then it represents aldehyde and ketone. Here we have example propanol and propanone. Right. So it is the third set of functional isomers. Fourth is acid and ester. Ester is the derivative of acid. We have discussed in nomenclature. So again we are going to compare acid and ester. For example, we have 2 carbon acid. This is ethanoic acid or acetic acid. And if we represent ester of 2 carbons, so it will be written as HCO CH3. So we can write the IUPAC name. This is methyl, 1 carbon chain methane, and suffix of ester is OAte. So this is methyl methanoate. And if we write their condensed formula, then it is C2H4O2. So here is the conclusion. If 2 oxygen atoms are there and hydrogen is just double, then that formula represent acid and ester. So we can write their general formula with respect to n carbon, and that will be CnH2nO2. It will represent 2 functional groups, acid and ester. So this is the set number 4 of functional isomers. Fifth is cyanides and isocyanides. They are also functional isomers. For example, we have RCN. R is any alkyl group, and isocyanide is written as RNC. This is alkyl cyanide and this is alkyl isocyanide. So we can say both have same molecular formula, but their suffix and their functional groups are different. That is quite easy, cyanides and isocyanides. And set number 6 we have set number 6 is quite important again. This is nitroalkanes, alkyl nitriles and amino acids. They represent one molecular formula but 3 different functional groups. One is nitro, second is nitrite, and third is amino acids. Let us understand with the example. For example, we have CH3, CH2, NO2. It will be written as nitro 2 carbon ethane, nitroethane. Alkyl nitrites. Nitrite group is ONO, bonding with oxygen and carbon. Here bonding is between nitrogen and carbon. So now it is written as alkyl nitrite, ethyl nitrite. And if we take amino acids containing one carboxylic acid group and other amine group, and we have to show only 2 carbons. So formula will be NH2 CH2 COH. This is amino acid. Now if we write their condensed formula, we have 2 carbons, C2, hydrogen we have 5, and in all these 3 structures we have one NO2 group here, here one NO2, and here NO2. So all these 3 structures contain NO2 group. So if we write with respect to n carbon, so formula is CnH2n plus 1 NO2. That will represent 3 functional groups. One is nitroalkane, second is alkyl nitrite, and third is amino acids. That is a quite important conclusion also. Nitroalkanes, alkyl nitrites, and amino acids, they all are functional isomers. This is our set number 6. Now set number 7 is alkynes, allenes, and dienes. Allenes means 2 consecutive double bonds are there, that those compounds are called allenes, and dienes 2 double bonds are present. They can be present at non consecutive positions. For example, we have 3 carbon alkyne, that is propyne. This propyne can be written with respect to dienes or allenes. This is allene, or we can say propene diene, prop diene. Now if we compare their condensed formula, both are C3H4. So alkynes and dienes or allenes, they all are functional isomers. This will show the characteristics features of alkynes, and it will show the features of alkenes. So both have different properties. So we can conclude both are functional isomers also. This is our set number 7. Set number 8 is set number 8 is also quite important. This is a phenolic group. if OH is attached with the benzene ring, then it is called phenolic group. But if OH group is not attached with the benzene ring, then it is called alcoholic group. We can see both have a same molecular formula, but two different function groups arise now. One is it will show the characteristics feature of phenol, but this will not show the characteristics feature of phenol. It will show the features of benzyl alcohol. And it is methyl phenol. We can write the position ortho. Methyl group is present at ortho position. So as the name indicates, this is methyl phenol. It will show the characteristic feature of phenol, but this is benzyl alcohol. It will show the characteristics features of alcohol, right? So this is quite important. Again, aromatic alcohols and non-aromatic alcohols, they are also functional isomers. So total we have 8 functional isomers, right? In next segment we will cover metamers and tautomers, remaining of structural isomers. So that's it for today. And if you are new to my channel, then please subscribe, like and share with your friends. Thank you.